The order of operations is a set of rules used to determine the sequence in which operations are performed in a mathematical expression. This ensures that everyone gets the same result when solving expressions. The steps to the order of operations are 1. Perform all operations within grouping symbols. There are several different kinds of grouping symbols that we'll look at. Most of the time, we'll look at parentheses. But we could have brackets or even braces. For this class, we'll mostly be focusing on parentheses, but do be aware that brackets and braces occur as well. If you ever have multiple sets of grouping symbols, you always want to start with the innermost grouping symbols first and work outward. Step 2 is evaluate any expressions that have exponents. Step 3, we want to multiply or divide in order from left to right. And then finally, we add or subtract, and again, we want to have a special order from left to right. Let's use the order of operations to simplify each of these expressions. Up first, we have 4 squared divided by 2 times 4. The first step in the order of operations is grouping symbols. Notice we don't see any grouping symbols here, so we move on to step 2, which is exponents. And we do have an exponent, 4 squared. 4 times 4 is 16. So this is equal to 16 divided by 2 times 4. The next step in the order of operations is multiply and divide, but we have to go in order from left to right. In the English language, we typically read left to right. We're going to do the same thing here. So when we read this in order, we are going from left to right. Notice that division comes first. 16 divided by 2. 16 divided by 2 is 8. Then we have 8 times 4. So just one more step here. 8 times 4 is 32. In example B, again, we want to follow the order of operations. Step 1 is simplify inside grouping symbols, which we do have this time. We have a set of parentheses. So we want to do that first. Inside the parentheses, we have 8 plus 4. That will give us 12. And then we'll simply copy down the rest. I highly recommend that you do one step at a time until you get very comfortable with order of operations. Sometimes you can combine steps, but until you're very, very comfortable with that process, I recommend one step at a time. Now that we've taken care of the parentheses, we want to move on to exponents. And we do have one here. We have 2 squared. So let's do that next. We'll bring down the 12 and the division symbol. And 2 squared, 2 times 2 is 4. The next step is to multiply or divide left to right. We do have some division here. 12 divided by 4 is 3. Now we have 3 minus 3. Last step, 3 minus 3 is 0. In the next example, we've got a lot going on here, so be careful, follow the order of operations. Step 1 is grouping symbols, which we do have a set of parentheses. We want to simplify inside those first. So we'll copy the 25, the minus 3, and the times. That is 4 plus 2, which is 6. So we have 6 squared. Then we'll just copy the divided by 6. Now that we've taken care of the parentheses, let's move on to exponents. We have 6 squared. So we'll copy the rest. 25 minus 3 times 6 squared. 6 times 6 is 36. Divided by 6. Now, the third step in the order of operations is multiply or divide in order from left to right. So notice we have multiply and division. We want to make sure we go in order from left to right. So we'll copy the 25. Then we have minus 3 times 36. 3 times 36 is 108. And we bring down the divided by 6. Next, we can do the division. 108 divided by 6. May need to do that off to the side. 6 goes into 10 once. 1 times 6 is 6. Subtract, we get 48. 6 goes into 48 8 times. 8 times 6 is 48. Subtract and we get a 0. So minus 108 divided by 6 is 18. And then finally, the last step, 25 divided by 18. 25 divided by 18 is 7. In example D, we have another ugly one. This time we have a big division question. Whenever you see something like this, I think it's easier to treat the top and the bottom as two separate questions and then simplify the very final answer with the division. By that, I mean, let's focus on just the top. Notice the top doesn't have any grouping symbols. So we move on to exponents. Again, just focusing on the top. So we have 7 minus 2 times 3 plus 3 squared is 9. And now let's focus on just the bottom. Let's do the first step of the bottom. Notice the bottom has parentheses in it, so we can simplify inside the parentheses. We have 5 times 2 minus 1 is 1. Focusing on just the top, we have multiplication. So we'll do that step next. 7 minus 2 times 3 is 6. Then we bring down the plus 9. Now in the bottom, we have 5 times 1. That will give us 5. Going back to the top, we have 7 minus 6, which is 1. We have plus 9. Just put the 5 in the bottom. Looking at the top, we have 1 plus 9, which is 10, divided by 5. And finally, 10 divided by 5 is 2. You went shopping today where you bought 3 shirts at $15 each, 4 pairs of socks for $2 each, 1 pair of shoes for $56, 2 pairs of jeans for $29 each, and 2 sweaters for $20 each. If you gave the cashier 5 $50 bills, how much change will you get back? Write a model to represent this scenario. Up first, you bought 3 shirts at $15 each. So we can think of that as 3 times 15. But we also bought 4 pairs of socks for $2 each. 4 times 2. And then 1 pair of shoes for $56. We can think of that as 1 times 56. 2 pairs of jeans for $29 each. 2 times 29. And 2 sweaters for $20 each. So 2 times 20. Let's see what happens if we add up these costs. Remember the order of operations. Multiplication comes before addition. So we can go through and multiply each of these. 3 times 15 is 45. 4 times 2 is 8. 1 times 56 is 56. 2 times 29 is 58. And 2 times 20 is 40. Finally, we want to add that column. Let's use a calculator to help us with this addition. 45 plus 8 plus 56 plus 58 plus 40. Here we get $207. So the total cost is $207. You gave the cashier 5 $50 bills. So let's talk about how much you gave the cashier. 5 times 50. Here, we get $250. So this is the total that you gave the cashier. How much change do we get back? Well, we gave $250, and we need to subtract the cost. 250 minus 207 gives us $43 in change. A farmer milks his cows twice a day. This morning he got 376 gallons of milk. This evening he got 382 gallons of milk. If he plans to sell 554 gallons to a local ice cream store, how many gallons of milk will be left? Notice that the farmer milked twice a day, so let's first figure out how much he got total. The first time he got 376 gallons. The next time he got 382 gallons. And we are adding these. Let's go to the calculator to add these a little more quickly. It looks like 758 total gallons. He plans to sell 554 gallons to the local ice cream store. So how much will he have left over? We have 758 total, but he's selling 554. So let's subtract that from the total. 758 minus 554. This gives us 204 gallons. So after he sells some to the ice cream store, he'll have 204 gallons left over.